All right. Welcome to Omega Matters, everyone, where we talk about all things omegas. I'm Kristina Jackson. This is Bill Harris. And today we are talking with a fantastic young researcher, Jeff Heileson. Jeff got his doctorate in nutritional sciences at Baylor University, go Bears, is a registered dietitian like me and a certified strength and conditioning specialist. And now he's a deputy director in the Nutrition Services Division at the Walter Reed National Military Medical Center. We first found out about Jeff and his mentor, Leslie Funderburk from Baylor, when they contacted us about analyzing samples for their studies. And then we found out the area he was working in was really interesting and really important. And that's omega-3s in athletics, and more specifically in concussion areas and strength building. So we wanted to bring Jeff on to talk about just three of his really interesting and impactful papers today. So let's get into it. Welcome, Jeff.
Yeah, thank you. Thank you for the introduction, and I appreciate being on Omega Matters because obviously I listen to it all the time, so it's always on in the background. So I appreciate being able to have a platform to talk about some of my research.
Yeah, we're
Great.
excited. We like to put a spotlight on the researchers because you're always in the background, just writing papers. So can you give us a little bit of your background? How did you get interested in this and land where you are?
Yeah, I was a little bit of a late bloomer from a PhD standpoint. I was the old man winter when I got into my PhD program. I had already been a registered dietitian for a little over 10 years.
Mm-hmm.
And then I decided to pursue a degree. I kind of made the decision in early 2018. And then I started looking at work I potentially go to. I was on a very short timeline.
Mm-hmm.
And so most people, they can sit around and probably do, PhD in like 3 years or longer.
Mm-hmm.
I had 3 years. I only had 3 years to do it. So I had to be very, very selective on where I chose, right? That was able to get all that through. And so I selected Baylor, and it worked out great. Rest is history. Yeah.
That's
Did
fantastic.
you actually do it on site in Waco?
Yes, sir, I did. Yeah, I definitely did it there. Spent 3 years there. What was good about it is that I started working with my mentor. This is probably what most PhD students do before they even get in, is I had been working with my mentor probably about 9 months before I even joined the school, just to start working on some small projects together.
Mm-hmm.
And so, because again, I was kind of I was already had almost a full career behind me, like halfway through a career already. And so I was pretty experienced. And so it was easy for me to kind of slip into that position.
Great.
Yeah. And so you're in working with military now.
Right.
We've started to work more with military. Was that always what you thought you were going to be going towards with the PhD? Or was that?
Yeah, actually. So I joined the military in 2008.
Okay.
And so I was a military dietitian up until then. I spent my first 2 years in the military doing a master's degree through Baylor. That program is actually at Fort Sam Houston, Texas, in San Antonio.
Okay.
The graduate program in nutrition, which currently still exists to this day. And we did 10 years of military service, and they have a program called long-term health education and training, and you can apply, and they'll send you to a school of choice to go get a PhD essentially. And I competed for that, and that's why I was on a 3-year timeline.
Yeah, that makes sense.
Because the military has very strict, they're like, we'll let you get a PhD, but you're on a timeline, you're on ours. So yeah. So now I'm now at Walter Reed, and I'm a research director here now.
That's fantastic. And that makes sense. Like, you've been so productive so recently, and you were also doing your studies over COVID. If
I remember
correctly.
It was a tough experience. I'll tell you that right now. It was very tough doing a PhD in the middle of the pandemic. It was very difficult.
When you're not working on rats and you're trying to do technical work.
I couldn't hang out with humans for a while, that's what my research is. So it was tough.
Oh, that's great. Thank you for sharing that. So let's talk about the first paper I wanted to talk about is a review. And it just kind of sets up this whole area. And I thought it was a really nice review. I've used it in some presentations. But it's published in 2020 in Nutrition Reviews. The effect of fish oil supplementation on the promotion and preservation of lean body mass, strength, and recovery from physiological stress in young, healthy adults, a systemic review. And this had a military focus. So can you tell us why you guys decided to do a systematic review on those outcomes in this population?
Right. Well, there's a lot of research, and well, I guess I'll backtrack a little bit. I mean, a lot of the research when it comes to the promotion and preservation of lean body mass, strength, is really centered around the other macros. The fat kind of gets left out of the equation a lot of times. And so it's pretty well established that, if you increase your protein intake during in times of basically physiological stress, protein is going to be like your biggest bang for your buck. Make sure then adequate carbohydrates on top of that. And then the fat's like, okay, just fill in the rest of what you need with your fat. But we really wanted to dive in to see what the literature said when it came to outcomes. There was a lot of really good mechanistic data that was very positive on the use of fish oil and how it could impact muscle protein synthesis. And there was some human data at the time that I actually put this together. But it wasn't very clear about, what the other data said when it came to these outcomes. And so I wanted to kind of put the data together and see what, basically see how it all panned out, really.
Yeah. And can you also define preservation and promotion of muscle mass?
Yeah, no, I appreciate it. Yeah, I definitely need to clarify that because that's one thing that I find in the literature is that you'll have a group of studies and they'll have particular outcomes, but just because the outcome is looking at lean body mass, it matters the context of when that occurs. So if you look at muscle damage protocols, for example, where you should have different outcomes related to strength, for example, versus a resistance training protocol, right? Those are diametrically opposed, right? One's in a state of preservation or you want to preserve strength, and the other one is you're actively trying to build strength. So that's what the promotion and preservation came from, because I found that a lot of reviews would put all the studies together and they would talk, basically they would have the studies talk to each other like we do in the literature, but they were kind of talking past each other. And I was like, why are they comparing those two studies? And so I was like, you know what, let's do a little bit better job of defining which studies are the most similar and which ones are trying to, for example, increase lean body mass versus preserve lean body mass. So we try to do that.
Jeff, you mentioned that protein has been one of the most focused nutrients in this area. Can you just briefly tell us how much protein is needed for preservation versus growth of muscle? Is there a easy
Right. Generally speaking, you can get lean body mass accrual or hypertrophy with anywhere really, if you want to cap it off, it's about 1.6 grams per kilogram with the resistance training protocol. I will say though, nutrition is only going to help a little bit. It's really, resistance training is kind of king when it comes to any type of lean body mass or hypertrophy or strength outcomes,
Right.
And then for and what was your other question? So you said
this preservation. Is there a difference? You're not trying to build, not trying to
right. Yeah, so the military has done a lot of really good studies. There's a real good paper in Nutrients that discussed the mitigation of mitigating the loss of muscle mass during field exercises. And a lot of that research really gave us some good ideas on how much protein actually can help preserve lean body mass. And in that context, they were able to preserve lean body mass as with protein intakes as high as I want to say it was 30% of their daily calories. It's tough to use percentage. It's better to use grams per kilogram, but I cannot remember off the top of my head how much grams per kilogram they used.
And more typically 20% of a diet is protein.
Right.
Yeah. So it's a pretty big difference.
Right. Yeah, it's a pretty big difference, right?
So like a 50% increase. Okay. So
we can
go back to fat now, but I was just having that protein question.
All the nutrients.
Oh yeah, no worries. Yeah.
They have their role. So I really think that you're dead on with this promotion versus preservation of muscle mass, because they also see this in the elderly and like sarcopenia type focused things. So what did you find? between and the effects of omega-3s in these two
Yeah.
areas.
Well, it was kind of unfortunate because really what we found is that mostly it was a lot of it was unclear.
Yeah.
We really couldn't hang our hat on any of the results. There wasn't a lot of information out there. However, we were very confident that it would help in situations of recovery, and how we, in that study specifically, how we measured recovery was we looked at soreness measures after muscle damaging exercise, range of motion outcomes, different types of swelling measures. Generally speaking, fish oil tended to do a very good job of helping folks recover faster after an actual muscle damage protocol. The second finding we had was that it was clear that there was definitely something there for preserving strength in instances in different contexts, wherever there was some kind of stressor. For example, one of the probably most well-known studies now is the McGlory study from 2019, looking at immobilization in females. And there was a preservation of strength in that study. So basically it protected the decline in strength despite immobilization. It was about a 35% decrease in strength in the fish oil group, and the placebo group was a 50% decrease, I believe.
Does that match with muscle mass? Is strength and muscle mass the same thing?
No, it's really not. It's a very, very big difference between. Now, there tends to be in younger individuals, they tend to be somewhat leaner, but it's not always the case. What that study found specifically, they actually found that it preserved lean body mass as well. So basically, the ability to rebound after. Well, let me correct that. So basically, after fish oil supplementation and immobilization, they lost approximately the same amount of muscle mass based on MRI in their leg.
Okay.
Right. But in the fish oil group, they gained, or they preserved some of that lean body mass a lot faster after 2 weeks when they measured compared to placebo. So they were able to recover faster.
Okay.
So it was the strength. Yeah. Right. It was the strength and the lean mass. So similar, there's a Philpott study where I think they decreased calories by 40%, like a pretty substantial amount of calories. So the whole goal was for them to lose weight.
Yeah.
And what they found is that fish oil did not preserve lean body mass compared to placebo. However, it did preserve strength. And strength actually slightly increased in the fish oil group, which was really interesting finding.
Yeah.
So there was something there related to fish oil being able to preserve strength.
Yeah, and I think it's a really important mind shift when you're looking at these studies and looking at the graphs. And like you said, in that one study, both groups declined technically in their strength as they were supposed to. Being immobile, you're trying to damage the muscle and immobilize, and all of these. When you get injured in real life, you have to do those. You have to stop using that muscle or that joint. But the omega-3s attenuate. They don't decrease as much. And we see this in the aging research is omega-3s will help attenuate like memory loss, and the placebo group will have a decline. So it's not making you smarter or whatever. It's not making you stronger just by taking the supplement. It's helping your body recover, and just through the natural stressors of life, it's helping your body maintain and be able to recover thereafter. Very different thing than I think is what maybe is portrayed media wise. It's different. It's a very different thing. So
I completely agree. Yeah,
I think that is fantastic. So since we've kind of clarified where this is happening, do you, with this information, how do you use it as an RD with who you work with? How does it change your recommendations, or how you explain why a military person would take it?
Right. It definitely clarifies for me, because it's one of those things where I've known for a very long time. I've been an RD since 2010, and we've known for a very long time that people just need to eat fish, right? It's not eat fish.
Yeah.
But what I found through my practice is that it was very difficult, no matter what type of motivational interviewing techniques you're using, it's very difficult to get folks to eat fish if they just don't want to eat fish.
Yep.
So what I found in practice is that linking nutrition to performance outcomes while you're counseling someone, it actually motivates them even more to try to do certain things. And this is a great example. So now that this evidence is starting to come out and it's starting to come together in different types of systematic reviews, I actually do break it down to my, to any kind of patients that I may have. And I'm speaking more to like the young folks, like I'm seeing typically 18 to 30-year-olds, majority from an outpatient standpoint. I actually talk to them about some of the performance implications or the potential implications, and I link it to that, and all of a sudden they start ticking up their fish intake a little bit. And so I definitely have seen that seen from my research, like a little bit of benefit of me being able to discuss that with patients.
Yes.
Now I will say all my research has been in young individuals, but I will tell you the biggest bang for the buck when it comes to fish oil and fish oil research is definitely in older individuals. The evidence is I think even a lot more clear in that population.
Yeah. I would agree with that, but I think a lot of the stuff that you're looking at still is it's impressive, but the youth is such an overwhelming variable that it's harder to see those effects. And in the military, are you only allowed to counsel for food? You aren't able to provide any supplementation at this point, is that correct?
Yes.
Okay.
Yep. We can only just counsel. We can't provide active supplements or anything like that. Yeah,
we've worked with a few people in the military about trying to increase fish options in the mess hall and things like that, and how to do it without supplementation.
So you can't, Jeff, you can't even recommend omega-3, never mind prescribe it, but you can't even suggest if you don't want to eat fish, you could do this.
Oh no, we definitely can recommend it for sure.
Okay.
Yeah, we just can't provide. Yeah, we just can't provide it.
Gotcha.
I mean, yeah.
Okay, that's a good clarification. All right, any other questions on the review we want to go over? I think that's it. Oh, the only other thing I noted was that you were looking at making sure you're getting a higher EPA supplement review. You want to discuss that just a little bit?
Right. Yeah, I definitely should have said that from the outset. Yeah, that was actually the bent we actually took with this systematic review, is that we specifically only looked at studies that had an equivalent EPA to DHA or a higher EPA. We did not include any other studies. And the reason for that is because a lot of the muscle protein synthesis data that's related to a lot of these outcomes was based on the EPA component. For example, the early cell studies, and actually the studies that are done in there was a study in steers, there's a study in pigs, and the early cell studies were very clear that the component of omega-3s that's actually increasing muscle protein synthesis was in fact the EPA component. And in one cell study, it showed it increased muscle protein synthesis and decreased breakdown as well. Which was pretty interesting. Again, that's not human data. But then fast forward to 2011, I mean, I would call them seminal papers now, from Mettendorfer's work. The first author is Gordon Smith, and his two papers are very famous now papers. And they found that in older individuals and in young individuals, fish oil substantially increased muscle protein synthesis response, or basically it sensitized the muscle to basically take in more of the available amino acids. And so that was a very important finding. And so because of that data, and again, they used an EPA biased supplement or infusion in that study, we decided to go with, okay, we'll hedge our bet and we'll look at EPA only. The higher EPA only. Yeah. Nice.
Yeah, that's interesting. I hadn't really, so that's kind of the mechanism they're thinking. One of the mechanisms, there's lots, is the membranes being enriched in EPA and DHA having a better uptake of the protein, carbs, all the other things that we know build muscle or maintain.
Right.
Cool.
What's the effect on mitochondrial function?
Yeah, there's actually been a couple of really good studies. I believe it was the same cohort that from the McGlory 2019 paper, but Miata actually looked at mitochondrial function, and they were looking at potentially, is that the reason why we're seeing these preservation effects in that immobilization model that they used? And they did in fact find that there was essentially the mitochondria was functioning more efficiently because of that. And because of that, it's utilizing less ATP. And so you're having less energy being expended at that point. And so what's happening is downstream, you're having all these other positive effects as well.
Interesting.
Right. So there is some stuff out there about respiration and mitochondria that it's a little bit outside my expertise, but it's very interesting data that's out there now.
And this review is very focused on the strength and recovery piece. And then there's this whole other area that's around endurance and oxygen.
Oh, right. Don't even get me started on endurance. Oh,
too big. It's too much. But let's shift gears. And now, so that was EPA heavy. And then we're going to talk about your work in concussion research, which is DHA heavy. Yeah. So the next paper is a randomized controlled trial that you are first author on. The paper is called "The Effect of Omega-3 Fatty Acids on a Biomarker of Head Trauma in NCAA Football Athletes, a multi-site non-randomized study." Or I guess it's a clinical trial, not a randomized trial. And this is the Journal of International Society of Sports Nutrition, 2021. Tell us how this study came about. And
this study was really interesting because I always thought it's kind of interesting because whenever I went back and I looked at the 2016 Oliver paper, so Dr. Oliver was the man in charge basically for this paper as well. And I thought after 2016, of course I was in practice, I thought there would be a slew of studies following the 2016 paper, because I remember in our world, how big of a paper that really was. But wow, fast forward a few years and there was nothing out. I couldn't believe it. So the goal of this paper was essentially to expand upon what was already shown in the previous paper. So I kind of have to go back a little bit to explain the genesis of this paper. So in 2016, Dr. Oliver showed that compared to placebo, 2 grams, 4 grams, and 6 grams of DHA only significantly decreased neurofilament light, which is a marker of head trauma. And it has a high agreement in the CSF or the spinal fluid, for example, and in serum. So it was an easy way to measure, how someone's doing over time, repetitive impacts. But what he also found, not only that though, when you collapse the groups upon each other, there was a clear effect where omega-3 significantly decreased neurofilament light. But another interesting finding on top of that, whenever you separated the groups, the 2 gram group actually outperformed the 4 gram and the 6 gram group. So it seemed to be the most effective dose. And so fast forward to the study that we're currently discussing, that we just published a couple of years ago. We knew we wanted to go with 2 grams of DHA, but we don't know what's going to happen though whenever you add EPA and DPA to the equation. That's why fish oil is really complicated, because it's complex. It goes into the body, it has multiple different targets, it can go into multiple different tissues. So we wanted to know if you added EPA to the equation, and we actually had, I think it was about half a gram of EPA and about half of that of DPA as well. And we wanted to see if it decreased the effect. And really what we found is we found very similar results to that 2016 paper, where it did actually, despite adding EPA, it did actually decrease neurofilament light compared to the control group. Again, we didn't have a placebo, we had a control team. Because that's another difficult thing with working with D1 programs or D2 programs or D3 programs, is that essentially when it came time to do a study, they're like, well, I want all of our guys to have omega-3 because we know it works. We don't want to have a group that has a placebo. So we had to have a control team, and that's how that worked out. And I also
so the main finding, so you preloaded, I like the design of this study because you guys started in preseason taking blood levels. Because and then you took it all the way through the season, right?
All the way. Yep.
All the way through. So
Yep.
you have like 6 different blood,
Yeah.
times when you took blood.
Yep.
Right. So you're able to like plot the increase in neurofilament light over the course of the season. So that like helps just more data to show that as a football season goes on, there's constant what are those called? Small head traumas. The big concussion, then just every day, every time you line up and run into another player, you're shaking your head a little bit and it's getting a little more brain damage. So it's like really building up over the course of the season. And then you're also able to measure the omega-3 index over the course of the season to make sure that that's hitting the targets that we would expect. And having you also, so that is, I wish I should, I'm going to show this. I'm just going to do this. I think this is the one I like. Well, both of these. So this is the same thing going on where we're seeing attenuation. So it's, and what happened in neurofilament light with the control team versus the supplemented team. And then you also looked at starters only because they are getting more of the hits than non-starters. So you can talk about all that.
Yeah. No, it was great because if you look at throughout the season, our omega-3 group, and this is extremely interesting, their neurofilament light on average only changed about 10%, an increase of only 10%. And if you look at any study that is a longitudinal design that looks at head trauma and neurofilament light, you think I was making that up because usually the difference is about double, right?
Really?
And then in our control team, we found that on average it was above 50% increase from baseline. So pretty substantial attenuation. So it was really interesting to replicate the findings essentially of the Oliver 2016 paper. Now, what was really interesting, so it is important to look at starters and non-starters in this context because of course they have more time, so there's more repetitive head impacts, right? So instead of getting hit by a truck 3 times, you're being hit by a truck 20 times, right? I mean, that's essentially what football players are doing. You're going out there and you're getting in American football, that's essentially what it is, you know, and we cheer for it. Yeah, we cheer for it.
It's I know. It's fun.
So we did find that there was a difference when we only accounted for starters. There definitely was a difference, but it wasn't as clear of a relationship. But we did find some. For example, in the control team, there was a significant elevation of neurofilament light when there was not a significant elevation in the omega-3 group still. Right.
Got it. Yeah. So that's like. This top one, you can see there's a lot bigger difference. That's that 10% versus 50. And then the starters, it's a little messier.
It is messier. Yep. Absolutely.
But that's real.
So. Yeah. Because I always tell people, I was like, you know, it's kind of an expectation with any type of nutritional strategy that it's not going to remove, like, there's nothing we can do to stop, like, for example, a concussion. Right. So no nutritional strategy is going to stop that. Right, it can only attenuate certain things, and this is one way to looking at that as well.
Yeah, it's really important that it is analyzed and shown in this way. And the other great thing is that you had blood levels that you were able to. I think they were given, so you have individual blood level changes, which I also like to see because then you do see some people don't go the right way.
Right,
that's real data, but on average. You see a big increase in the omega-3 index for the ones supplementing. And 2 grams a day is also, I'm grateful that was the most effective dose because 6 grams a day, it's a ton. It's too much.
That is a lot.
For like a lifetime. So 2 grams a day is something that it's just to see those kind of effects and these big guys who are doing lots of activity.
Right.
Because we do see in some other like in soccer players, we've seen just over the course of the season a natural decline in the omega-3 levels in their blood if they're not supplementing.
Right.
And they
did you see that in your control group too?
Yes.
your control team?
It's, I think, overall. Mhm.
Small
Decrease,
drops in
yeah.
the omega-3 index, okay.
And
Yeah.
yeah, so that just adds the validity to this paper that this is truly people taking the supplements and getting it incorporated into their body, which is really necessary. Did you guys do any analysis of like the change in omega-3 index and change in NFL? Just like those correlation type of
No,
things?
we didn't. And that probably would have been nice to do, because, fast forward to 2022, there was another paper published on this, by Mullins.
Mhm.
And they did that type of analysis, and they did find that there was a relationship. I believe the correlation was, I think it was 0.4, an R of 0.4, which is just not bad.
Yeah.
That's good stuff. Yeah,
Yeah,
0.4.
with messy biological
I know.
markers. That's good.
Yeah, so they found a pretty good, a moderate to strong, correlation related to, as the omega-3 index goes up, neurofilm light goes down, and the Mullins paper showed that.
Yeah, so that's, I mean, that kind of consistency is critical. And so not only concussions are a problem in sports, but in the military as well.
Absolutely.
So this, I mean, implementation wise, again, is this kind of data, is it kind of the same thing of like, this is good, but it's not like, we really need to get our guys who are most at risk for a concussion, who are like, I don't know if that's people who are actually out on missions or what, but how does this information change how you work and maybe how your colleagues work with individuals?
Well, yeah, it has the biggest impact on our special forces contingencies. I think those are, it's easier to influence a smaller group, right? Because, we talk about the conventional forces, that's a large number,
Yeah, it's too
half
big.
a million, half a million individuals. But special forces, and they're exposed to these types of environments more often as well, to where they could potentially have a lot more repetitive head impacts, blast injuries, those types of things. So I wrote a short review paper called The Application of Fish Oil Supplementation in Special Operators. And that's the reason, because that's probably where the biggest bang for a buck when it comes to educating our forces. It'll definitely be in our special operators. And so, I'm currently on a working group right now, working on trying to figure out the omega-3 issue, trying to see if there's a way we could leverage this knowledge to help our special forces get everything they need.
So you can't recommend supplements to them, but you can recommend omega-3 enriched foods, right?
I can do both. I can recommend supplements for sure.
I just probably provide omega-3 enriched foods.
Right. So they've done a couple of dining facility studies where they've tried to increase the omega-3 environment. But the way they've gone about it, though, unfortunately, is that they've just decreased the N6 items, like the oils and those types of things. So I think the better way to do it would probably be to increase the omega-3 footprint but again, that costs a lot of money too, honestly, to increase the amount of N3s, because I think that's a better strategy.
Right.
Yeah. And are there smoothies being served to people? Because that's like usually an easy place to get, extra protein, and sometimes you can put omega-3s in there. Is that something that's considered food or is that?
Yeah, it would literally have to be given as like a self-contained, so it could be, it could be self-contained, but that's definitely something to look into for sure. I know they just did a study with the enhanced recovery, which contains like protein and omega-3 as well.
Okay.
So it's definitely something to look into for sure.
Yeah, implementation is a whole different, like you have the study, you find it, and then then all of these structures in the real world that you have to work around and figure out. It's wild, but it's the founding, like these controlled trials are really important, and hopefully do push implementation, because it is going to cost money. Prevention costs money, and a lot of these, again, you are somewhat preloading with omega-3s, is that right? And then you need to have a high level in your body when the impact happens to have a lower NFL.
Yeah, so the whole thought process is to have a membrane driven hypothesis, and part of that is essentially preconditioning.
Mhm.
You know, I did a talk and I called it nutritional armor because
Yeah.
someone called omega-3 nutritional armor like in 2014, and I just like, oh, that's a great name. I'm gonna use that.
Yeah.
And that's kind of what it is. You're preconditioning the tissues to ensure they have adequate amounts of omega-3. So when there is an assault, whether that's, you know, we talked about the preservation, whether that's through head trauma, just
Mhm.
so the tissue has that ready to go essentially, for those effects to occur.
Yeah.
Yeah.
Yeah. And so that's where it's one of those things. You can't just start taking it after you're injured and expect to see these effects. It's having it on board. So you don't know when you're going to get injured half the time. So you
Yeah.
might be, it's like an investment in your health that it's a lot harder to convince people of that than I'm
Right.
injured, give me something. All right. Hurt.
Very true. Yeah.
Yeah. So
Well,
it's
we
tricky.
do know that there are products being being developed in intravenous emulsions that can be administered
true.
immediately after a concussion.
Right. And that's like high, huge
That's
doses.
high doses, right?
Uh-huh.
Direct into the
Yeah.
blood.
But that stuff, that's really interesting and cool. And they use that on, I think, Shazier, the NFL player with the massive back injury.
Oh, okay.
And they
Okay.
did like cold treatment and high infusion of omega-3, I'm pretty sure.
Yeah.
And it worked.
Yeah.
N of one.
Yeah, that's an area of research that we're definitely definitely would like to do more on, is the recovery phase, so acute and chronic recovery phase after a concussion.
Mhm.
The research is very difficult to do, but that would be a very interesting on, because there are certain protocols I know that are out there. I know Dr. Lewis,
Mm.
Mike Lewis, has a
Right.
protocol that he uses as well. So it'd be good to actually formally test that if possible. Yeah, I agree with that.
And those doses are
Very high.
likely going to be very high.
Like 9 grams or higher, I think is what
Yeah.
they're.
Yeah.
Yeah.
So it's not like it's not something that you can just recommend to anybody, obviously.
No.
So they have two different purposes. But
Right.
so now, so we've talked about kind of EPA and muscle preservation and things like that, and then DHA in the brain. And how do you kind of reconcile that? Where you kind of get like, oh, DHA is good for this, EPA is good for this. And then of course it's like, just take both. But do you tailor
Yeah.
it all when you're talking to people on that?
Really, I don't.
Right.
I really don't. I'm just like, you know what? You need to take fish
Right.
oil. And once
Yeah.
I get them started there, now when I'm working with, if I'm ever working with, you know, one-on-one with like someone that's in that type of environment, like special courses, I definitely would give recommendations that are more tailored to the individual.
Mhm.
You know, if it's someone that I know that is exposed to a lot of head impacts, then I definitely would recommend a DHA bias supplement.
Mhm.
If it's someone that is just working out in general, I would go with a standard fish oil supplement, which is higher in EPA, typically your standard
Mhm.
off the shelf.
Yeah.
I would probably just recommend that in general because it's still going to get them some DHA as well.
Right. Having both. We get asked about what's the ratio of DHA to EP all the time, or should I just do one or the other? And it always ends up like
Yeah.
they come together in nature and they
Yeah.
both do really important. In research, it's nice to tease it out a little bit, but at the
Right.
recommendation stage, it just changes a little bit. But you're most of the time we want both happening, both in the supplement.
Yeah. At the end of the day, we just want them above, 4% of omega-3, like from a
Let's not get
public health and a population standpoint. They got to get above 4%. I mean, that's
right.
basically it.
And a lot of different outcomes. Pregnancies where I focus mostly, it's just all of the action when you supplement is happening at the lower levels where you can see those big effects in the research. There's more and more probably subtle effects as you get to higher levels and comparing. And then when we look at the longitudinal data, we see a dose response where you're still getting like lower and lower risk for heart attacks and dementia and things like that at that 8%. But for other things, if we can just population wise get out of a deficiency state for most people, that'd be a big step. And that's more around the recommendations of the 200 or 2 servings of fish a week. That's what that would do, is it would get you out of 4%.
Right.
It won't get you to 8%.
Absolutely it won't. Yeah. It takes
So
a
that's
lot to get there.
also, that's confusing to people, but they do have two different purposes, I think. Anyway, that's my soapbox. Let's talk about your last paper.
Okay.
This is the Journal of International Society for Sports Nutrition again, 2023. So hot off the presses. This is the effect of fish oil supplementation on resistance training induced adaptations. So you're kind of going into the land where you're like, we don't have enough research in this area, where I feel good about talking about muscle promotion. So tell us about the study. Tell us what you found.
Yeah, so yeah, exactly. Coming straight from the systematic review, that's why this exists today. We wanted to do a resistance training protocol because we know that's going to increase strength and lean body mass, especially in young individuals. And there was some question marks because McGlory published two papers, one in 2014 and one in 2016. And the 2014 paper showed that, well, look, if we have young individuals, give them fish oil, they actually increase certain markers of, I'll say muscle protein synthesis, but I'll just say that for ease. But there was very specific markers that they looked at to see the influences. And so it was like, okay, well, this data exists. Well, in 2016, he published another paper and it showed that it does not increase muscle protein synthesis in resistance trained individuals. So after that paper got published, there was like almost no data, and no one was working on it because everyone kind of saw that paper and like, well, there's nothing there. It's smoke and mirrors. We're going to move on and go to older individuals where we can have see some of those effects. I was like, well, there's something there though, because the difference was nearly 30%, a 30% difference in the increase in muscle protein synthesis. So although it didn't reach statistical significance, I wasn't ready to give up on it, And so fast forward after our systematic review, we put together the study. So it's a 10-week resistance training protocol, which is tough to do. It's tough to do a resistance training protocol. And we followed folks for the whole 10 weeks. And we did DEXA scans as our proxy for muscle mass. We used lean body mass from that. We did dietary food logs to track their nutrition. And we did dried blood spots through OmegaQuant before and after as well. And then every 2 weeks, we would distribute their supplements. And so we had multiple ways to kind of track compliance. Obviously, because we're measuring red blood cell, or excuse me, the whole blood through a dried blood spot before and after. And then obviously we were doing supplement distribution. So when they bring it back, we know how much supplements they actually took in. So we had multiple different ways to kind of track that. And so at the end of the day, what we found after a very long time and a very tough, we had 7 dropouts, unfortunately. I think I cried after every dropout. We found some really interesting results though, because our hypothesis hinged on muscle protein synthesis. That was our primary hypothesis for almost everything. Well, interestingly enough, we found that there was no statistical difference in lean body mass between placebo. And again, resistance training is king, and they both significantly increased their lean body mass. And so what was even more interesting though is that there was a differential effect that favored fish oil related to strength. We found that absolute strength was increased in bench press, and then relative strength was increased in both metrics, in bench press and the back squat.
So
which was a very interesting.
Versus relative, what does that mean exactly?
Yeah, so absolute is just how much weight did they actually lift regardless of their own weight. So how much weight did they lift before and after? Relative was relative to body weight. So right, and we know that there's differences, for example, because we included both men and women in this study. And we weren't looking at sex differences. We included both. And looking at relative is really good when you have a mixed cohort with men and women, because they tend to increase relative strength similarly, and there's without anything else changing. Right. So absolute strength though can favor males majority of the time. Right. And so we wanted to look at both metrics. That was something we planned previously. When we put the protocol together. And so it was really interesting because some of the research in older individuals looking at anabolic resistance and how fish oils could potentially help older individuals overcome that anabolic resistance. Part of that hypothesis is that it increases muscle quality. So basically the amount of force you get per gram of muscle increases. And our results hint that that might actually be the reason why we see differential effects related to strength outcomes in older individuals. Even though our study was in young individuals, it definitely lends some credence to that belief regarding anabolic resistance and how it improves strength.
That is so interesting. It's a quality versus quantity type of thing. And I think most people in their heads, like you said, the more muscle you have, the stronger you are. That's what people think. But that muscle can be more or less efficient. And that's where the strength really comes in. What you actually really want is that function of strength. And is that like when it comes, this is maybe off topic, but when it comes to bone health also, the resistance training is really important. Is the strength aspect of muscles more or less important for the bone health, or is it just the lifting is it totally separate, or do you think there's some kind of connection between how much bones are being strengthened with weight training and how well the muscles are functioning?
There's definitely some crosstalk, I believe. Yeah, there's definitely some crosstalk, and I think they're both really important. And having the weight bearing, right? Because we have certain mechanisms also in the muscle that hinge on, being able to just like you add weight to something, right? So, yeah, so that's part of it. So you have nutrients and stimuli that affect certain things. Well, in this circumstance, you also have any kind of weight bearing also upregulates a lot of those protein synthetic machinery, essentially. And it's upregulated by just adding weight.
Yeah.
Actually, having an opposable force actually does. Yeah. So I think there is some crosstalk though related to bone health as well.
Yeah.
That's interesting. So yeah, I think so. At the end of the day, you did kind of confirm what you found in the review, in that it was strength that was affected by fish oil. So I guess do you have anything else you want to talk about on that paper? And if not, what's next for you? What are you looking at and studying?
Oh yeah, well, just related to that paper, it was absolutely insane. We had someone with an omega-3 index of like 16. That was wild. I had to point that out. It was absolutely wild.
What was the dose you were on? This one was, I think I looked at this. Was this 7 pills a day?
Yes.
Yeah, that was a big one.
These poor souls, it was almost 4 grams of EPA.
Yeah.
Substantial dose.
You're really hitting them hard.
And the reason
something.
Well, the reason why we did that too is because again, everything's related to the membrane. So we know from previous studies that it takes about 4 weeks to significantly increase, and clinically, where it's clinically meaningful, to increase omega-3 status in the muscle. And so we really had to give them a substantial dose because the studies that show that actually gave 5 grams of EPA plus DHA. So a very substantial dose. So we wanted to make sure that we increased even though we're measuring the blood, we wanted to make sure it was increased in their muscle. So we knew we had to give a substantial dose. And that's why the study was 10 weeks long. It's because we know the first 4 weeks were slowly increasing. For us, it probably took about 5 weeks for them to maximum or to get close to what I guess would be considered a maximal amount of omega-3 in their muscle. And so we wanted to make sure we had enough time to get there.
Yeah.
So were you at steady state in a month or 5 weeks, or 10 weeks was no higher in the muscle than it was at 5?
Well, see, that's the problem. We did not measure muscle. We only measured the dried blood spots. So we only have dried blood spot data. Yeah, that would have been nice to measure muscle, but we couldn't do biopsies at the time.
Yeah, but we have seen red blood cells, which the whole blood metric is very, very well estimating that are highly correlated. The membrane changes in the red blood cell are really highly correlated with muscle and spleen and not the brain.
Right, not the brain. Yeah, that's the interesting
Heart.
one.
Yeah,
we still don't really know how it increases the brain. That's a whole different conversation, but but that's a tough one, how it gets into the brain, or if it even does, at what, that's tough. But yeah, the correlation between red blood cell and muscle in humans, I believe one study showed it was like a 0.9, an R of 0.9. So a very strong relationship between those two.
For EPA and DHA specifically.
Right.
Yeah,
EPA and DHA.
Yeah, those two are different. So these are fantastic. Are you working on any new studies that you can talk about, or are you going in this direction, or what is your next step?
Yeah, actually, I'm just now trying to get around to publish my final study from this. I actually had another study that's muscle damage. We also did a muscle damage study. And we looked at, backtrack all the way to the systematic review we first talked about, because that's where it comes from as well. We found that was a clear finding. You're like, well, why in the world would you want to look at recovery if someone's already done it?
Yeah.
Well, what we found, a big gap in the literature, was we don't know which omega-3 is having that effect. Is it DHA? Is it EPA? Is it EPA plus DHA? So we studied it. We had 4 groups, a placebo group. We had a placebo group, an EPA only group, DHA only group, and then an EPA plus DHA. And so hopefully we'll get that published. Very high dose.
Grams. Yeah.
4 grams.
Okay.
We use Carlson's because they have 1 gram pills. They have capsules that are actually 1 gram of EPA and then 1 gram of DHA. Unfortunately, they're not the same form. The EPA is ethyl ester and DHA was triglyceride. But we substantially increased their omega-3 index, like regardless, right? It still went up. Even with EPA, it went up quite a bit too.
Yeah.
So I'm hoping to get that study out. We did find some differential effects with EPA plus and DHA. So some interesting findings. So I'm hoping to get that published out soon.
Yeah. Well, this is all great stuff, and we hope you keep publishing and bringing this is such an important area and a really we need it in a lot of the areas that you're in the military and our sports and our athletes. Also looking at our younger athletes, we've wanted to do studies in youth football teams because we want to start preserving that brain earlier. But it's hard. It's really hard to run these studies. So good job. Thanks for running them. And thanks so much for talking to us today.
Absolutely.
Yeah. Oh yeah, no, and thank you guys so much for the opportunity, because it's anytime I get a chance to talk about, you guys are probably the only ones that want to hear me talk about omega-3, so I really appreciate it.
This is all, everyone loves this stuff. This is great. Thanks so much, Jeff, and we'll be in touch.
Thank you, Jeff.
All right, thank you. Bye.
Bye-bye.
All right. That was great.